So if you look at people as they get older and you look at what they're afraid of, there are a few things. Now, from a health perspective, they're probably more afraid of losing their memory than they are of getting cancer.
And I realize I probably would never see the results myself, but if they can find out information about me, it could help my children, my grandchildren, and not just my family, but others who might be affected by this or their families.
The more understanding we have of any of this is important, and we'll do anything that helps any understanding.
We are on a cusp of a renaissance in understanding brain function for the first time.
The concept is futuristic. The setting seems pure sci-fi. But this science isn't fiction, and the future is today. During the past century, science has conquered many of the body's greatest challenges. But while brain-related disorders affect 2 billion people in the world at every stage of life, this most important organ has remained largely a mystery. In partnership with the Village's Health, unraveling that mystery is the mission of ElMinda, an international medical technology company that has spent the last decade revolutionizing brain research.
Our first aim is to create a very big database of information to understand how the normal and abnormal brain looks like as we age. Because early detection is the best prognostic indicator for any disease, our goal is to detect changes in our brain as early as possible and to intervene.
ElMinda's innovative tool, Brain Network Activation, or BNA, is a new approach to understanding how the brain functions for creating a baseline of what is considered a normally functioning brain and combines the ability to compare multiple tests over time.
You know, if you think about how healthcare has to work, a lot of times you have to say, we understand abnormal because we understand normal. So this really is the first step towards understanding normal.
Before we can go on and take a look and say, well, let's study disease or let's study abnormalities in the population, you have to ask the question, do we really know what normal looks like if you held it in your hand? And then you have to ask the question, is normal for a 40 or 50-year-old the same as normal for an 80 or 90-year-old? So you would be looking at decade-specific changes in how the brain functions in healthy populations, people that are willing to volunteer to be studied, all right, that will be able to establish what the background normal is. And you need a lot of people to do that, as you might imagine.
To find a high concentration of seniors willing to take part in a study, ElMinda found what it was looking for in the Villages, Florida. Home to more than 120,000 residents, the Villages is the world's largest retirement community and represents an unparalleled source of senior participants that are key to ElMinda research.
You know, the Villages is a very special place. We do have a community research board. The community research board approves all of the potential research that we do. When the ElMinda folks came and Carla came and presented to the community research board what we were looking for, the answer from the community research board is we think that this will have great opportunity for people to feel like they're contributing to future generations and their health. And because of that, the people that live here have a strong willingness to contribute to that. And a number of the community research board folks wanted to be involved in the study. And I think it just speaks volumes.
So BNA to date has been used really very successfully in the treatment of concussion, predominantly with younger people. As you know, a lot of younger people like to play sports. They play sports like football or soccer, basketball, where their risk for concussion can be quite great. And the great thing about BNA is it allows us to collect baseline data, so to get a snapshot of what people's brains look like when they were healthy before they've sustained any kind of injury. And then if they do get a concussion, do another BNA test with them, look to see what the impact of that concussion has been on their brain, and once they're fully healed, let them know that they're fully healed and safe to go back to their sport. Because if they go back to their sport too early, they can be at risk for what's called second impact syndrome, where if they sustain another injury on their brain that may already be swollen, they can be at risk for things like stroke and potentially even death.
By seeing a patient's change in electrical brain activity after an injury, physicians can make more informed decisions for treatment and more accurately recognize recovery. The potential applications of BNA technology are far-reaching. Beyond injuries, diseases can disrupt the brain's electrochemical network, leading to dysfunction that can now be measured, thanks to BNA.
It looks like there's a real opportunity for us to start to use BNA technology to examine other very important conditions like depression, like aging. But it also offers us potentially the opportunity to be able to identify things like Alzheimer's disease earlier, to be able to identify things like depression, to potentially, and most hopefully in the future, be able to think about what kinds of medications maybe might be right for one person, and to really personalize medicine in a way that's going to get people the most effective treatment as fast as possible, and to help increase their quality of life as soon as possible.
So this technology is giving us new information and new tools to help us to apply therapies that have the best chance to work. And we can prove it very quickly. So with this tool, we don't have to rely on large controlled population studies, entering people in blinded studies that could take decades for one question, does this drug work? We can quickly study many different therapies and simply look at how the results differ. We don't have to worry about placebo effect.
With diagnosis for diseases like Alzheimer's increasing at alarming rates, facing the possibility of dementia is often a greater fear than cancer for some patients.
In the last 2 decades, most of the studies of medications for Alzheimer's were started in people that were too advanced, and it's now thought we need to repeat a lot of those questions at the earliest possible time. How do we discover the earliest possible time? That is to say, Alzheimer's is a process which may be going on before people themselves recognize that they're having some trouble with memory.
Research has really shown us that people think that there are starting to be structural and metabolic changes in the brain, probably as many as 10 years before you actually show signs and symptoms. If we can do early detection even earlier, that we might be able to use a tool like BNA to see when you're having some changes in your brain health before you even actually are starting to experience forgetfulness or other kinds of symptoms that we might be able to see. If we've caught it early enough that they could still enjoy a lifetime of good quality of life, and potentially even one day get to a cure.
While BNA technology is highly sophisticated, the process of being tested is relatively simple.
So there are 2 things that we collect. One is an individual's baseline, and an individual's baseline really gives us an idea of what their brain function looks like today. And the great thing about a snapshot of what your brain function looks like today is that it allows us to compare what you personally look like today and what you personally look like in a year. If you have a stroke or you start experiencing signs of dementia, I can actually see what did you look like before you started experiencing those symptoms, what do you look like a year out from that or 2 years out from that, so I can get some better understanding of how you might be changing over time. And we also collect what is considered to be a normative baseline for the population at large, so that I'll have a better understanding of what's typical for people who are between the ages of 60 and 65 or between the ages of 65 and 75. So I'll be able to tell you that this is what your personal brain looks like in the future. And also I can tell you your brain looks very similar to other people who are in your same age and gender class. So it looks like your brain is as healthy as we might expect. So if you don't have a baseline map on file, that I would be able to, at least down the line, compare your personal data to what's normal for people in your age group, and at least be able to move forward if you are experiencing some signs or symptoms.
Following a physical and mental health survey, along with a memory test, participants wear an electrode net while doing a series of simple computer tasks during an EEG recording. A 3D representation is created showing what brain function looked like as it responds to the pictures and sounds. There is no pain and no risk involved. Time is the greatest commitment, with participants to the research study required to attend 4 to 5 2-hour visits over a 15-month period. Participants benefit by gaining access to personal BNA brain maps that will allow monitoring of changes over time. And they have the potential to help others age successfully and healthily by providing baseline measurements for normal brain function.
There There is, as you get older, a sense that your time on this planet is numbered. And for many people, giving something back in the forms of being a contributor to the advancement of science is an incredibly important thing.
So the ElMinda folks said, we're looking to do something with elder adults and hopefully something along the dementia route, and what better place than the villages to find elder adults who are willing to participate and help.
Nowadays, so many people are affected by different forms of dementia, and if there's a way that we can one day solve that problem for so many people, I would love to be part of that solution.
ElMinda's BNA technology is setting a new standard of brain health care that will ensure peace of mind over the course of a lifetime. For more information, please contact villagesresearch@gmail.com or call 352-247-2493.